There are many ways to represent an ellipse. We'll discuss two of them here. Let's start with the familiar formula for a circle. X squared plus y squared equal to r squared, which represents a circle centering on the origin with a radius of r. Equivalently, we can divide both sides of this equation by r squared and get x squared over r squared plus y squared over r squared equal to 1. Here comes the magic. If we replace r squared in the denominators with a squared and b squared, respectively, and let a not equal b, we will get an ellipse. This ellipse still centers on the origin, with its two axes lying on the x-axis and the y-axis of the Euclidean plane, respectively, and the half-length of its axis is a and b, respectively. You may wonder, what if the ellipse is not centered on the origin and its axes do not lie on the x and the y-axis of the Euclidean plane? In that case, it's helpful to use the vector function formulation. Here, x, c0, q1, and q2 are all vectors. Specifically, x represents any point on the ellipse. C0 is the center. T is a parameter from 0 to 2 pi. Lambda 1 and lambda 2 are the lengths of half-axis. Finally, q1 and q2 are direction vectors for the axis. It's important to note that q1 and q2 are unit length vectors, and they are orthogonal to each other. Now, what is the relationship between this type of formulation and the one we just talked about? Let's delve into it. Based on orthogonality between q1 and q2, we find the dot product between x minus c0 and q1 is cosine t times lambda 1, while x minus c0 prime times q2 equals sine t times lambda 2. Rearrange the formulas and divide both equations by the half-length of their corresponding axis. We get x minus c0 prime times q1 divided by lambda 1 equals cosine t, and x minus c0 prime times q2 divided by lambda 2 equals sine t. Square up both items and add them together, we get cosine t squared plus sine t squared equal to 1, which is very similar to the previous formulation. In the next video, we'll show how to draw ellipses and circles in GeoGebra. And that's good for now. If you enjoyed the content, please like, subscribe, and comment. Now go enjoy life.